Kavin. This is my ICP-7. ICP-7 is about reading the content from the web URL and saving it to a text file. Apply some NLP techniques on the text file and train a machine learning model using k-neighbors classifier algorithm. So coming to the program, so we use the beautiful soup to get the content from the URL. So beautiful soup is a Python library for pulling data out of HTML and XML files. So first one, it creates an file input.txt, and the second one, it gets the text from the URL, wiki URL, and we use the HTML parser to get the content from the HTML. So this is the content from the web URL. The third part is creating some NLP techniques. Before that, what is an NLP technique? So the first NLP technique is tokenization, where in tokenization, if we have a sentence like this, we would make each one of the words into a separate element in the list. This is word tokenization, and sometimes we might need sentence tokenization, where we divide the whole paragraph or the content into sentences. The second one is parts of speech, POS. So say we have a sentence like this: the little yellow dog barked at the cat. So we would find what parts of speech it belongs to, the word belongs to, for optional determiner, or it's an adjective or a noun, or it's a noun phrase, etc. The next one is the stemming. So in stemming, what we do is, if we have something like words like linguistic, we make it to linguistic, inflected to inflect, sometimes to sometime, derived to derive. So by making this, we could identify words which are similar. For example, if we have a word like morphology and morphological, both determine the same word. So morphology is morphology and morphological is also morphology. So this is why we use stemming. Next one is bigram or trigram. So we make the words to, for example, if it is a bigram, we make two words from the sentences. If it is a trigram, we'll make it to 3 or 4, etc. Next one is the named entity relations, entity types. For example, if a person, we would say it's a proper people, including fictional, or if it is Tuesday, we would say it's type data, type date. Or if it is Asia Pacific, then we would say it belongs to a location. Next one is TF-IDF. The TF-IDF vectorizer will tokenize the documents, learn the vocabulary, and inverse document frequency weights. So we run this, we could see the output. So we apply first tokenization on the text file, next create stemming, next lemmatization, next apply trigram and named entity relations. So first one is tokenization. We would see in sentence tokenization, each one of the sentence from the text file is separated, and in word tokenization, each word is taken from the content of the file. Next one is stemming. Let's say we have a word this, then this THI, THIN this. If it is an article, we would remove the E part and company, etc. Next one is lemmatization. In lemmatizers, let's say we have this article is about the, then we would find what is the, we apply lemmatization on top of it. Next one is the trigram. Let's say we have a sentence like this article is about the company, then we would make it to First, we'll make it a bigram, that is two words in each of the elements in the list, and the trigram three words in each of the list. Next one is the name entity relation. So say if as company it belongs to NN type, or if it is yes it belongs to verb, if it is article then noun, etc. The last part is applying the k-means, where in k-means each of the word we find how to classify each of the data points into clusters, and the first one is normal k-means. Next one, use TF-IDF vectorizer, like what we discussed earlier. The TF-IDF will tokenize the DOCOM, learn the work library, and inverse the one's frequency weightings. And the third one is use the stop words English. The stop words, like for example, if you have a sentence like geeks for geeks or computer science portal for geeks, words like a, for is not needed, so we'll remove all those words. So using normal KNN, we got multinomial NB, we got 77% accuracy, and KNN 92% accuracy. In same data, if we apply n-gram range from 1, 2, so using n-gram range, we got accuracy of 92%. Now applying these stop words, that is removing the stop words. So we have got some increase in using the stop words, that is to 81% and 92%. So on using only the k-name classifier without using any TF-DF, we got 77 and 92.5%, but when we use the n-gram range from 1, 2, you could see there is a drop in the accuracy from 77 to 76 and 92.5 to 92. But when we use English remove the stop words, there is an increase in multinomial MB, that is from 77 to 81, which is very huge, and there is a slight difference between the KNN. But when we use the both, we got increase in multinomial NB, and there's slight difference between KNN. So there was no change from the KNN when we change the parameter of vectorizer, but we could see a change using the parameters in multinomial NB. That's it. Thank you.